Did you know that sometimes diamonds just fall from the sky? Platinum, nickel, and gold too. Even though this might sound like a joke, it's entirely possible. The chemical composition of meteorites includes all kinds of substances, some of which are quite valuable. Although platinum is indeed rare among them, typically meteorites are just plain boulders. This totally makes sense because most likely they're just fragments of ancient planets. Imagine throwing a rock at a glass bottle. The swift motion of the arm, the whooshing sound, the glass shattering into dozens of shards. According to one theory, this is more or less how meteorites came to be, although on a different scale. Millions of years ago, a planet was silently making its way through the expanses of outer space when suddenly it met another large celestial body and burst into pieces as a result of the collision. Larger fragments continued their existence as asteroids, and smaller ones became meteorites and meteors. Each of these rocks has a trajectory of its own, determined by the collision of the billions of planetary fragments flying through space. A few come close to Earth and even fall on our planet. Here are some figures to give you an idea of the scale of this phenomenon. 93% of all meteorites falling on Earth are stony. They may have iron or more manganese inclusions, but mostly they're plain rocks with a fusion crust on the surface. About 6% are iron meteorites, meaning more or less what it sounds like. They are made up of good old iron, plus maybe a bit of nickel. And only 1% of all space rocks contain something truly unusual. It may be diamonds, platinum, gold, but only as small inclusions. If a meteorite consisted only of gold or platinum, it would never make it to the Earth's surface. When falling down through the atmosphere of our planet, meteorites may reach the speed of 72 meters per second, which is more than 160,000 miles per hour. Naturally, the space rock gets heated to unbelievably high temperatures, easily reaching 2,500 to 3,000 degrees Fahrenheit. It can even heat to 18,000 degrees. Now, gold melts at just about 1,950 degrees, and at 5,200 degrees, boils and evaporates. So unfortunately, the most curious space rocks simply do not reach our planet's surface. Then again, when talking about space rocks, we should take a look at what is happening in space. In space, things get really interesting indeed. Meteorites on Earth are rather tiny. Okay, they may reach 20 pounds or 50 or even 100. The largest single-piece iron meteorite found on Earth, known as HOBA, is estimated to weigh over 60 tons and measure slightly less than 9 by 9 by 3 feet. But honestly, can you call this large? Essentially, an asteroid is a meteorite as well, only tremendously more massive, the size of a small planet. The solar system has hundreds of thousands of discovered asteroids, 700,000 as of 2017, and the overall estimate is 1 to 2 million. The bulk of them orbits the Sun somewhere between Mars and Jupiter, which in space terms is not so distant from Earth. What sort of things can we expect to find on asteroids? Basically the same as on Earth, except air and life. For instance, asteroids have water, frozen into ice, but water nonetheless. As we know, water is made up of hydrogen and oxygen, so in theory, it is possible to break these vast slabs of ice into breathable air and rocket fuel. Granted, today we don't have the technology to accomplish such a task, but scientists are working on it. However, water is not that common on asteroids. Unlike carbon, 75% of all asteroids so far analyzed by researchers are carbonaceous. Not exactly fascinating, since coal and graphite are quite common on Earth as well. But carbon may also mean diamonds, and that is definitely something worthwhile. The second most common are stony asteroids. They make up 15% of the overall number and are indeed boring. The remaining 10% are metallic asteroids, for which scientists have high hopes related to the possibility of mining for valuable ores and minerals. We've already mentioned gold and platinum, and it's common knowledge that gold is cool and plays a central role in the global economy. However, in reality, precious metals are not necessarily the most expensive or sought after. The modern high-tech industry has a huge demand for other elements, some of which command incredibly high prices. Let's take, for example, a rare and really expensive metal, osmium. The world's annual output of osmium production reaches only a few dozen pounds. As of 2018, it sells for $400 per troy ounce, and that price had held steady for more than 2 decades. 1 ounce of palladium has a price tag of $1,050. This amount might fail to impress compared to osmium. But gold is just slightly more expensive, and gold is a rather abundant commodity, while osmium is in short supply, which is getting shorter by the year. If you've never heard about rhenium, don't be surprised. This is a rare metal. The global supply of it is estimated to be a mere 13,000 tons. 1 pound of it may cost up to $4,500. Rhodium is another rare metal, with the global supply of 30,000 tons and the price tag of 1 ounce currently being $700. Rhodium is indispensable for manufacturing certain high-tech products, and its overall quantity on the planet is not growing. Other metals that can be found on asteroids include ruthenium, nickel, and molybdenum. This is an entire treasure trove worth of metals which are rare on Earth. And let's not forget iron ore. However common and boring, maybe iron is the foundation of all heavy manufacturing. A single-mile-wide asteroid may yield up to 2 billion tons of rich iron ore. To put this figure in perspective, the worldwide iron ore extraction output currently reaches about 3 billion tons a year. That's all countries of the world taken together. Basically, one small asteroid equals a little under 70% of the global iron output. Somewhere between the orbits of Mars and Jupiter, a huge asteroid named Psyche circles around the Sun. This celestial rock, 157 miles wide, consists almost completely of iron-nickel alloys. An ore cache of this size could satisfy the needs of humankind for millions of years. Of course, iron and nickel aren't in the same league as diamonds. The latter is an epitome of perfection and elegance, while the former are simple, crude, and cheap. And yet, last year's net profit of the smelting giant Norilsk Nickel amounted to $3 billion, while the same figure for the largest diamond producer, De Beers, came to only $1.5 billion. Let's not forget that De Beers is almost a global monopoly, unlike Norilsk Nickel, which is merely one of the larger players in their respective markets. So, if you find a magic lamp and a genie offers you a choice between ore and diamonds, pick ore. On second thought, precious metals on a cosmic scale are definitely something to think about. In 2015, the asteroid UD-158 passed by Earth. It was really small as they come, just 1,050 by 500 feet. This space rock, too tiny to even have a name, contained 100 million tons of platinum. That's at least $300 billion in current prices. But platinum wasn't the only metal it had. Scientists believe the total price of all ores contained in this asteroid would add up to $5 trillion. Now, if you recall Psyche, the 157-mile wide metallic asteroid, its total worth is estimated to be 10,000 quadrillion dollars. To imagine that, since the entire economy of planet Earth is worth 78 trillion bucks, that one asteroid is worth 128,000 times the world's economy. There is the question of what will become of the prices of metals in the world's economy once the space ore finds its way into the market. Will the global market be able to absorb the deluge of gold and platinum or crash under the weight? Perhaps we will soon see. Currently, scientists are working on 2 different approaches to asteroid mining. The easier option is to try and catch a small asteroid by hauling it closer to Earth, at least to the vicinity of the Moon's orbit. This operation is likely to be entrusted to robots and involves an unmanned space station approaching the asteroid, hooking itself to it with special anchors, and pulling it in the needed direction. Sounds like science fiction, but this is actually quite practical. About once in near-Earth orbit, the asteroid will be mined. But the process will not require digging actual mines with the ore located close to the surface. Mines won't be necessary. It'll be enough to shatter the surface layers and catch the flying fragments with a magnet. In the low-gravity conditions, this won't require much power. The device scientists are planning to use looks like a rake with magnetic prongs. Another tool for extracting ore in space is the good old, basically the same thing prospectors used during the California gold rush. In low gravity, it works with incredible efficiency, much better than on Earth. NASA began the project 6 years ago. Currently, the unmanned station is still at the design stage. Spacesuits for future prospectors, however, are already being tested. Astronauts are practicing coming down on the asteroid surface. According to estimates, towing the asteroid to a near-Earth orbit will cost $15,000 to $200,000. That isn't that expensive considering the potential payoff. The second option is even bolder. In 2014, scientists came up with a project of a robotic expedition to Psyche. The authors hoped that the probe would launch from Earth in 2016, but the initial plan failed. However, the idea wasn't altogether abandoned. The timeline was adjusted, with the launch scheduled for 2022. The probe is supposed to reach Psyche after a 4-year journey and spend another 6 months moving around on the asteroid, collecting data and sending reports to Earth. Of course, Psyche cannot be towed to Earth, but robots can fly to Psyche. They can sift through the soil, collect ore samples, pack them, and send them wherever operators will tell them to. And no, the destination is not going to be Earth. The idea is to construct transshipment stations in space with headquarters on a near-Earth orbit. This huge station will become home to the experts who will control the extraction process, as well as the fuel and food warehouse. Further in space, smaller refueling stations will be built. The last outpost in the line will be the Operation Control Unit, from which operators will run the robotic extractors. The ore samples gathered on Psyche will be first studied and classified there, and then sent on down the line. At the moment, however, most of this is a matter of theory rather than practice. Today, scientists still haven't figured out how robots can function on the surface of a metallic asteroid in low gravity, where they will get power from mining, or how much power they will require. After all, this is not about digging mud. The extracting machines will actually have to cut through iron, and that should require considerable power. Nevertheless, things are moving on. The US is already developing, or rather updating, the legislation concerning property rights on mineral resources. The problem is that one international treaty on resources has already been signed back in 1967. The US, the UK, and the Soviet Union agreed that countries cannot claim ownership of celestial bodies or their parts. This implies that resources on asteroids cannot be owned by a country or a private entity, but belong to all humankind. As of today, almost every country in the world has signed this treaty, but in 1967, no one seemed to take the treaty seriously. Come on, what property rights on celestial bodies? What resources on asteroids? Yuri Gagarin had already been to space, but Neil Armstrong's moonwalk was still 2 years in the future. Nowadays, it's a different story. In 2015, the US Congress started working on another law, which would give the right of ownership over asteroid resources to individuals or companies. The Treaty of 1967 is regarded as carrying no legal weight. It's hard to imagine that an international treaty signed by 126 countries carries no legal weight. But there we go. At the moment, it's not clear how things will play out, but hopefully the infinite resources of space will serve the interests of all humankind, rather than corporations. And that's it for the time being. We hope you enjoyed the video, and thank you for watching.